Hi, this is M. Prasad Naidu. Today we are discussing about the radioisotopes. Introductions. This is a composed it is a atom is composed as an effective positively charged nucleus that surrounding by the could be forgetting negative charged electrons. The number of orbital electron is equally to the number of protons present in the nucleus. This number is known as atomic is Z. The sum of protons neutrons in a given nucleus, the mass number like A equal to Z plus n number of neutrons, and denotes number of neutrons. The definition like is a isotopes are nucleoids with the same atomic number but different mass number. The spontaneously degradation of nucleus, transmission of the one element to another with consequently emission of the rays of particularly is known as radioactivity. There are different types of radioactive decays. The decay is like a negatron emission, positron emission, and particularly emission. This decay gamma rays emission, X-rays emission, decay it is by the negatron emission when neutron is converted to proton by the ejection of the negatively charged beta particle called as negatron. It is emitted charged particles like a neutron is proton and negatron. So decay positron emission, when proton is converted to neutron, a positively charged particle known as positron is emitted. Proton it's reduced to neutron plus positron. Positron are extremely unstable there despite their energy interaction with the electrons. Decay a particular emission by a particular emission. Isotopes elements with high atom numbers frequency decay by emitted particularly alpha particle. So electron captures an electron orbiting in the innermost shell. So proton is combined with the electron to give the neutron plus X-rays. Proton becomes a neutron, electromagnetic X-rays is given out. Decay emission of X-rays, T-rays. This emission, Y rays resulting from the transmission in the nucleus of an atom in contrast to X-rays emission and frequently accompanies with alpha and beta particle emissions. The emissions of gamma radiations leads to no charge in atomic nucleus mass. Gamma radiation has low ionizing power but high penetration. Half-life of radioisotopes. Units of radioactivity, the definition and measurements of radioactivity, various methods for the measuring the radioactivity: autoradiography, gas ionizing detectors, fluorescent scintillation are the basis to detect the measure of radioactivity in clinical laboratory. Autoradiography. In autoradiography, a photographic emulsion is used to visualize molecules labeled with a radioactive elements. The emulsion consists of a large number of silver halide crystal embedded in a solid phase of such as a gelatin. As a energy from radioactivity active material despite in the emulsion, the silver halide becomes negatively charged is reduced to metallic silver. The photographic developers are designed to show the silver grains as a block laying of the film, and fixers remove any remaining silver halide. The techniques autoradiography becomes more important in molecular biology especially. Choice of emulsion and film. The X-ray films are generally suitable for the macroscopic microscopic samples such as whole body electrophoretic graphs, chromatographs. When light or electron microscope detections of image cellular, subcellular localization, radioactivity, very sensitive films are necessary. The times exposed and film process depend on isotopes, sample type, levels, activity, film type, and purpose of the experiment. In the direct radiography, the X-ray film or emulsion is placed as a close possible to the sample. The fluorography is to cut short the time of exposure. A fluorescent material such as PPO solidate infiltration to the gel. The intensifying screens, the other methods amplifying the image. The sensitivity of film is increased by pre-flashing. The pre-flashing involves millisecond light flash prior to sample is being brought to juxtaposition with the film. The low temperature of exposure will provide higher sensitivity. This is gas-filled detectors. These gas-filled detectors filled with the gases or gas mixtures designed to measure the ions produced by radiation within the detector, extracts existence, ionization productions, pulse of current. Like a scintillation counting. The applications of radioisotopes in biological sciences. Radioisotopes are frequently used tracing of metabolic pathways, mixing radio-labeled substrates, samples, experimental materials, collecting samples at various times, extract, separate the products by the chromatography. Radioactivity detectors can be attached to gas liquid chromatography or high performance liquid chromatography columns to monitor radioactivity coming of the column during the separation. It is possible to predict the fate of individual carbon atoms and acetate to TCA cycle, tricarboxylic acid cycle. Methods have developed to isolate the intermediate of the cycle and to the eccentric distribution carbon atoms within the intermediate. This is called a specific labeling pattern. Radioisotopes are used in eccentric turnover times for the particular compound. The group of rats injection with the radio-labeled amino acids for 24 allowing to assimilate into the proteins. The rats are killed suitable time interval and radioactivity in organs or tissues interest is determined. Radioisotopes widely used in study of the mechanism and rate distribution, rate absorption, accumulation and translocation in inorganic or organic compounds in the animal. The analytical applications radioisotope, the virtually any enzyme reaction can be assayed using radioactive tracer methods. Radioisotopes have been used in the study of the mechanism of enzyme actions, also in the studies like ligand binding to the membrane receptors. Radioisotopes used in diagnostic purpose also. The radioactive iodine uptake imaging reveals the functional status like thyroid tissues including the nodules, thyroid nodules like a whole thyroid gland and mastocytic foci like isotope 131, 123. These are the isotope 131 is thyroid cancer imaging magnetic isotope, 123 radioactive for thyroid scan. Some of the therapeutic uses. Radioisotopes also magnetic and malignancies. Isotopes role in management of malignancies, tumors attacked in the radiations. It is also isotope 121 is thyroid cancer treatment. Radio hazards, immediate effects, radio safety and protection. Thank you. We are discussing with these things. Thank you very much. Radioisotopes